Our presentation deals with the influence of an oil coating lacing the inner surface of a glass on the formation of beer head foam. Beer head foam is a white bubble formation at the top of the liquid beer that forms after pouring beer into a glass. There are different styles and techniques of pouring a beer that can minimize or maximize the beer head depending on your preference. We chose to experiment pouring a beer straight into a glass with no oil lacing the inner surface as compared to pouring beer straight into a glass with oil lacing the inner surface. As the experiment pictures show, the oil drastically minimizes the formation of beer head, almost to the point of which there is none. After observing this phenomenon, we came to our hypothesis that the oil must affect the surface tension of the beer. We believe that the oil decreases the surface tension. We know the smaller surface tension means smaller bubble radii, thus producing a smaller beer head. We conducted the research to see if oil does indeed affect the surface tension in the way that we had thought, or to find out if maybe something else is involved.
Okay, so for our initial analysis, we assumed that the mechanism by which olive oil is reducing the surface tension of beer is the simple fact that olive oil has a lower surface tension than beer. So when you mix the two together, you get an in-between value. And so if most of the olive oil rises to the surface because it's less dense, then we'll get best case scenario, we'll get a surface tension that's infinitely close to the surface tension of olive oil. So now we have an equation for bubble radius, and it uses surface tension and density. And so beer's surface tension on average is going to be about 45 dynes per centimeter, and density very similar to water. The oil surface tension is about 32 dynes per centimeter, and density of about 0.92 grams per centimeter cubed. So now we can make a ratio between the two. Everything else cancels out because it's going to be the same. And we get 0.77 to 1 ratio for the radii of the bubbles. So now if we assume that the number of bubbles is constant in the two glasses, then we can estimate the ratio between the head volumes, because we know that the volume of the spheres is proportional to radius cubed. So we cube the top and bottom and we get 0.46 to 1. And we also know that the radii in the glasses is also going to be the same. So the ratio of the heights is also going to be 0.46 to 1. So what all this means is that the foam head that forms on the beer that is poured into the olive oil coated glass is going to be 46% as tall as the foam head that forms on the beer poured into the clean glass. So now this was a good attempt, but it didn't actually justify what happened in our experiment. And so after more research, we found that lower surface tension is actually conducive to more foam formation. So the number of bubbles is not going to be constant. And we've got another thing going on here, and that is surfactants, which are basically proteins in beer that have hydrophilic heads and hydrophobic tails. And so when there's no oil in the glass, these surfactants are going to align on the surface, and they're going to act as to lower the surface tension of the beer, making it more conducive to forming foam. And so when we introduce oil, those hydrophobic tails are going to want to come down and join the oil rather than stay on the surface. And so oil is stealing surfactants from the surface, raising the surface tension of the beer, making it less conducive to foam formation.
In conclusion, what we have learned is that the oil actually increases the surface tension at the interface between the air and beer. As we know, this means that the beer, in a sense, holds together more tightly, allowing less foam to be produced, which involves separating beer to form bubbles. However, we have also learned that what oil introduced purely to foam does is the opposite. It allows the foam to coarsen, merging smaller bubbles into larger ones, reducing the number of bubbles until they are no more, or, in other words, increases the rate of drainage.